Our next speaker is Giuseppe Bruno. Giuseppe is going to talk with us about the Lustre installation that he performed at the Bank of Italy. I'm hoping that he'll show us some file system comparisons. Come on up. Giuseppe Bruno, ladies and gentlemen.
So to change the slide?
Yeah, here it is. The right is forward, and then
forward,
you
okay.
can hold it.
Oh, I see. I see.
Okay.
So this way.
All right.
Okay. Good afternoon, everybody, and thank you to the organizing committee for inviting me in making this presentation. First of all, I would like to tell you something about the fact that we are going to, in my talk, we are going to see a file system that is way down the sizes that we have been talking this morning. Like I've heard many times petabytes, even exabytes file system with petaflops performances. Here we are going to discuss a file system that is used in a very small scale, but it has its own peculiarity. And of course, I'm not. Yeah, sure. Sorry. I was saying that we're going to show a file system with very small size with respect to the one that we have been seeing during the morning. And here we have a short outline of the presentation. I will first say something about the reason and the goals of the paper, of the presentation. Then I will provide some elements on the research area and its computer needs. We have been hearing this morning about the need for having a workload from the users, and this is a sort of attempt to provide a workload for our users. I will then explore the feature of the employed hardware platform at the research department, and also the way we arranged the Lustre architecture in our file system, and the way we arrived at this file system. Then we will see a short comparison among other three file systems that were available, and I will also say something about the storage area network that we have put in place, and I will then discuss the requirement, the specification for our file system, and I will provide some lights and shadows of our experience, because of course it's not been complete lights and night and good things, and I mean that is more a question rather than a statement, because of course I will leave a question to the floor whether some of the problems are lack of knowledge or software issues itself, and I will provide some concluding remarks. So let's start from some motivation. First of all, we had to modify the computing platform that we had at the research department. We started from shared memory IBM AIX platform, and we wanted to move to a distributed memory platform based on industry standard platforms. As I was saying before, we have a very small file system, essentially just a 10 terabytes file system, but but with a lot of small files. So we have about 13 million files that belong to about 400 people that are logging from different computing nodes. And the two questions that we were facing were whether we could provide a reliable and fast access to the file system, and whether we had a simple and transparent migration path for our users. So the research department of the Bank of Italy is composed essentially by 400 people in the headquarters in Rome, plus another 100 that are spread among 20 regional branches in the regional capitals of Italy. And the researchers are assigned different tasks, and among them the most important are they compile statistics, they produce different reports, and they run, of course, a research project and employ some web applications. The most relevant fraction of the computing tasks are interactive sessions that are carried out using end-user packages like MATLAB, SAS, or SpeakEasy, or Stata, or R packages, and a few of them, these are just the youngest that are coming in the recent years, are starting using some Fortran or C++ application for taking advantage of the parallel structure of the platform. Essentially, right now they are just using OpenMP. Now here we have a picture describing the initial hardware platform that was released about 16 months ago. So we have essentially two sites. We have a symmetric distribution of computing nodes between two sites that are geographically separated by 25 kilometers away, just for disaster recovery purposes. And with the blue colors, I represent computing nodes. So we have 5 computing nodes on one side and the other 5 on the others. And with this violet colors, I have the initial Lustre servers. And then I have also a test platform. The green and the gray, dark gray rectangular are the test environment. Now we have the upgraded hardware platform. We at the beginning of this year we upgraded the production cluster. The testing cluster is remained essentially the same. So we added 2 computing nodes on each side, and we added also an extra Lustre Server Lustre Server nodes on each of the 2 sites. Here in this other picture, I hope we can understand also from the end of the room that we have the network connections with the virtual SAN and the virtual LAN for the HPC network and for the toward the fabric switch toward the storage. That is an HP 24,000 storage. Now I will describe the initial configuration of the Lustre Server architecture that was initially configured with only 2 servers, and in one of them we were running in a regular condition the MDS and the MGS on the 030 nodes, and we also had one OSS with 3 OST. On the other, on the 31 node, we had only one big OSS running 9 OST. And this is the structure of the cluster, because on these two nodes we were running Red Hat cluster suite, and the red line is just dividing what we had on the first node and what we had on the other node. The upgraded Lustre Server that was upgraded just a few months ago, we have been able to have the MDS and the MGS only on one node. On one, all these nodes are AMD Opteron based nodes, and so we decided to have just one node running the MDS and the MGS servers, and on the other we were running an OSS with 6 OST. In case of failure, this red lines means when we have a failure on the other node, so we pick up the OSS service, and of course we serve all the other OST requests. And the other nodes that we added, the other two, are devoted only to OSS. So they each run one OSS for node in regular condition. In failover condition, of course, they have to run double OSS. And here we have the distribution of the services on this other cluster. So we have on the two node 30 and 31, we have a different situation, because on the 30 now we have only the MDT, the metadata target and meta management server, and on the 31 we have 6 OST. The other two servers, the other two nodes, sorry, that run another Red Hat cluster suite with these two services. So they have each an OSS OS server for 6 OST. Now a bit of experimentation and the history. Before landing, say on Lustre, we started with the GFS, and we couldn't make up with our applications. And also we tried with OCFS, the Oracle file system, and also with this file system, performances were almost acceptable, but we didn't have quotas, support for quotas on this file system, so we couldn't run our applications. This table has been produced by preparing some scripts that build a sort of a graph structure in the file system. So they make a directory, and then they write files, and then they write some bytes with the DD inside these files. And now a few words about the storage area network. Also the storage area network in this 16 months of life has its own evolution. We started with 2 racks distributed in the two geographic sites, with a total of say about 40 terabytes distributed among the two sites, and in each of this storage array we grouped 8 disks in a RAID 5 plus hot spare configuration, and we deployed 4 fabric switches in double mirrored configuration for reliability purposes. And 2 months ago, in February, we added extra 48 disks, different size, 300 gigabytes, all SAS disks, for a total of 7.2 user terabytes. And now some elements about the use of the storage area network. So we started, this is the initial configuration when we have only 2 Lustre Server. We started with just the 12 OST, they were all the same in size, with the MDT that was just 100 gigabytes. And we put almost 40 million inodes to allow for the high value of high counts of files. And then we moved adding this extra 6 OST, and we can see in the red rectangular shape that we have this OST that are completely unbalanced with respect to the previous one. And we have almost doubled the number of inodes, so we can face increase in the number of files. So let's say something about the requirements for the file system, because I've heard here many applications where there are huge file system, but with file size very big. So we open a file and we read a lot of bytes from it, or we write as outcome of operation on one single file. In our case, we have a distribution that is highly left skewed. So many files that are, 50% of the files are less than 4 kilobytes. And the average, the arithmetic average is just half megabytes. So we decided to use just a stripe count of 1 and the stripe size of 1 megabytes. So essentially, all these files reside in just one OST. And we recently set the quality of service parameters for the free space and the round robin to this 89% and 16%. And these parameters should speed up the OST balancing. And here I have 2 histograms of the distribution of the size of this file system. The file system is divided into 2 big sections. In the first section, I have files for the groups, so are a pool of users, researchers. And here we have just the home directories that are, so the distribution is about the same. Here we have some parameters of the maximum threads and minimum and maximum threads that we can open on the different Lustre server. And here we go to some of the most important things of the presentation according to my view. Essentially, we started with the version 1.83 in February 2011, and we immediately found a problem with the chmod command in directory who had the set group ID on. So on those directory, the change mode had a very strange behavior because user not belonging to the group could even change permission to the directory. And we started modifying the change mode code for a while, and then after a certain amount of time, we received a modification for Lustre. Then we had other problems with common environment between the Samba software that we are using to allow Windows users to see their files and to share their files with other colleagues through the Linux storage SAN. And we found problems with these opportunistic locks that were raised by Samba and were not honored by the Lustre lock system. And then we migrate from 1.8.3 to 1.85 in June last year. And even after that, we kept having crashes on one of the Lustre server that was hosting the MGS MDT server. And then the other problem that we found was the difficulty in managing quotas distributed among OST. I heard a presentation about the future prospect of the quotas, and I really hope that the quotas will be taken care more carefully. As far as the Samba locks is concerned, I can say that we have discovered that while Samba tried to use the lock mandatory, Lustre tried to use the exclusive lock, and it doesn't recognize the mandatory lock. So we get this kind of error. As far as the quota is concerned, of course, even the 1.8 manual states that there are known issues with the quotas, and some of them is that using. I mean, my bottom line is that using quotas in Lustre File System can be quite complex, and there are several known issues. One of them is that we didn't quite understand the policy with which the general quota is distributed among OST, and why it's possible that in some situation that we haven't been able to reproduce, we can have the AD quota, the error on quota exceeded on one OST, even if we didn't overcome the total quota allowed to that group for that particular configuration. Quite recently, at the beginning of January, we modified the quota switch parameter, disabling the dynamic changing of the Q unit and B unit, and then we migrate to 1.87 in March 2012, so just a couple of months ago. And from January, the platform seems more stabilized. The only problems that we had recently are just related with quotas. That's the only thing that is left in our setup. So now some conclusion. I think that deploying a Lustre file system when there are many small files can be quite challenging. Quite challenging might mean that it's difficult because maybe we need right consultant, and maybe we didn't have right consultant at the very beginning. Another problem is that even matching good performances doesn't mean that the system is resilient and stable. So, I mean, quality, we have seen in the previous presentation, quality is a sort of multidimensional attribute. It depends on performances, on resilience and stability of the system. And the question is that maybe the design of the file system doesn't fit completely our requirement. That's something that is not easy to answer. And also the Samba server doesn't seem to fit smoothly on the Lustre file system. Maybe we will separate the server in the next release. And also, last comment is about managing user and group quotas might be probably improved by offering quotas that are tighter to the user needs, because right now we have to put very high quotas to each group and user to let him go smoothly. And okay, and thank you very much for your attention, and I'll be glad to answer your questions.
You mentioned what was the previous file system you used?
You mean before? Right. So I already got a question from the first line. Anyway, so before moving to a distributed file system, we used to have just a shared file system with NFS because we had just two nodes before when we had the previous AIX environment. Could you speak?
Did you use clustered Samba configuration or use single Samba server to export Lustre file system?
No, you mean the Samba?
Samba have a configuration where up to 6 Samba servers can be export a single file system
Yes.
or several files. So I have interested, you use this configuration or use single Samba server to export?
Single, yes.